Okay, it's 1 o'clock. Welcome everybody to our weekly HDF clinic. It's all about your questions. If you are here for the first time today, welcome. If you are a returning visitor, you're very welcome too. It's all about your questions, and I checked our Google document earlier. There was just sort of the hangover or the question that was asked last week, but that was asked for to be answered during today's meeting, and we are happy to oblige and do that. So that's what we'll do. But before I go into that question or that set of questions, I just want to ask if there are any other questions. I will ask many more times the question whether there are any questions, but if there are any other questions right now, let's bring them out and I can start thinking in the back of my mind about potential answers. So any questions you might have right now, speak up, or otherwise I'll just continue. Okay, good. So let's jump right in. So the three questions basically that were asked last time, but the person was unable to attend, was there was a question about H5 Repack, this tool, and whether that's how I interpret the question. If you run this tool with certain options on an existing HDF5 file, once you use that file with your application, do you expect any change in performance, read performance, for example? And the answer is very likely, but maybe before we go there, let's just remind ourselves what H5 Repack actually can do for you. So I listed sort of a few highlights. H5 Repack, again, unfortunately, the HDF5 command line tools, they probably were inspired, obviously, at least for the naming, by sort of the standard Unix tools. And the good news about or one of the strengths of the Unix tools combined with a shell, of course, is that you can combine them in many different ways, and that each tool is very good at doing one thing. So they are well factored. It's not that tool X overlaps substantially with what tool Y does and so forth. So the Unix tradition is pretty strong there also in the refactoring department. The HDF5 command line utilities, however, have a lot of baggage and duplication. That has historical reasons. So it's not that nobody thought about that, or that sort of independent teams develop these tools and they just try to outdo each other and try to create sort of the general problem solver tool. That's not true. But there was an element of that some of these tools were developed for certain projects in the context of certain projects, and then were generalized and so forth, and that led sort of to this overlap and this patchwork. And unfortunately, it would be quite an effort to go back and refactor everything, and I think at some point we will do that. But for the time being, if you look at the tools, there is a lot of overlap, and we'll actually, if we get sort of to the end of this meeting, the material that I have prepared, we will actually see an example of there are two tools, two very simple tools that do something very specific that H5 Repack also can do. So it's unfortunate, but that's what we have to live with for now. Okay, back to H5 Repack. What can it do for you? Well, number one, it can reclaim unused file space. So let's say you have an HDF5 file. For a variety of reasons, there could be unused space. Unused space, for example, could be present as a result of you having written some data to that HDF5 file, and then later deleted a data set, closed the file, and at a later point gone back and added new data and so forth. Especially if you used an older version of the library where what we call free space management, the tracking of those areas in the file that are no longer in use by any data set or other structures. If you use such an older version, that will just show up in H5 dump or in H5 stat as unused space, and you can get rid of that space programmatically, but more convenient. A more convenient way to get rid of that space is to use H5 Repack to repack your file, and then H5 Repack will discover that unused space, and well, it will not actually consciously discover that space because there is no metadata in older versions of the file format to discover that free space. It will basically just take the objects that are there and rewrite them as densely as it can in a new file, and that way the unused space automatically disappears. So that's one common use case, is reclaim unused file space. Another is upgrade to certain file format features. As you know, okay, there are all these different library releases, 1.8, 1.10, 1.12, and that will just continue. But in the background, of course, the HDF5 file format is also evolving, and you don't notice that as much because of our forward and backward compatibility with the library, that a given library can read all file format variants that predate that library, and it can also read all future versions of the file format, as long as you don't use in that file features that were introduced after that library version was released. And then, of course, the latest version of the library can read all previous versions of the file format up to that point. And so it can happen, to give you an example, if you take a popular tool like MATLAB, for example. I believe it's currently based on the 1.8 family of libraries and the underlying file format. So if you would like, if there is a feature in HDF5 1.10, for example, then you would have to upgrade that file when you, from an application or otherwise, open that file. You have to, in a way, upgrade the some of the infrastructure, some of the metadata, to signal to the application that it's okay to introduce some new features, some new primitives in that file that are not backwards compatible with 1.8. And one way to achieve that is, for example, H5 Repack, to basically say, use the latest or use the 1.10 sort of level file format. Another one is you can change dataset layouts. As all of you, I'm sure, know, datasets can be laid out contiguously, chunked, they can be compact, they can be virtual, they can be external. So there are lots of different flavors. And H5 Repack is a convenient way to explore that. So what that does is really, it just changes the physical layout of your data in the file. It does not change any values. It doesn't do anything to the values. And on top of that, some of these layouts are compatible with applying compression, chunked in particular. So in addition to changing the layout, you could then experiment if you think that your data is reasonably compressible and so forth, so you could reduce the file size quite a bit, then H5 Repack is a perfect way to explore that. And again, H5 Repack can do a lot more, aligning data in the file and so forth. This is an incomplete list, so if you want to get a full picture, just run h5 dump -- help, and that will give you sort of a slew of options. So coming back to the question, now, does H5 Repack have an impact on read performance? And the answer is very likely. However, that very likely sort of cuts both ways. It cuts both ways in the sense that your read performance could be better. Your read performance could also be worse, and for different reasons. So let's maybe give one example each where that can happen. Or yeah, so let's start with the good news. Is let's say, for example, you have a data set that is small, and by small I mean typically 64 kilobytes. So you have a data set that is relatively small, and it was created, let's say, with the default creation options. Then it would be what we call contiguous layout. So there would be some metadata that corresponds to the data set, and then at some offset in the file, there would be a contiguous range of bytes in the file that holds the data set values for that data set. Now, in terms of read performance, when later an application reads that data set, there would be kind of two read operations. First, the library would read sort of what we call the object header, basically the thing that describes what is the type of the elements, what is the extent of the data set in the sense of what is its dimensionality, what is the extent in the different dimensions, and so forth. And then it would find sort of the offset in the file, the address where that contiguous range of data set elements is, and then read from there. Now, as we said, well, if that data set is small, what you can actually do is there's this option called a compact storage layout, where you basically, since it is small, kind of attach it to that object header, to that piece of metadata that sort of describes that data set. And what happens then is, if you read from the data set, rather than needing two or more read operations to get a hold of these data set elements, what the library will do is it will read the object header, but it will read the physical values of that data set in the same swoop. So you're getting away with one read operation, and that typically results in better read performance, especially if you do that very often. I mean, if you do that just for one data set once, probably the difference between then that additional seek operation and read is not going to break the bank. But if you do that very often and so forth, you will definitely see a cumulative effect of better read performance. Now, the counterexample, under what circumstances could something like that backfire? Well, it could backfire, for example, let's say it turns out your data is actually not very compressible. So, and not very compressible. To make matters worse, sometimes when you apply a compression algorithm to a data set for which it is not really suited well, it could be that the compressed, in double quotes, data set is actually, if you just look at the size in megabytes, that the compressed data set is actually bigger than the original data set. So that can happen. And in that case, of course, it's very likely, depending on how bad this bloat, I mean, the HDF5 library will detect this, and it will correctly then write that bigger compressed, in double quotes, data set. However, yeah, unless you, if you do this programmatically, there will be an error code, and then that error code will tell you that this is what has happened. But if you don't process that error code, the library will just write it and not tell you that that's what happened, and you will discover that sort of after the fact. So it can happen in both directions. Typically, you will know, or you will have a feeling, and that's why tools like H5 Repack are nice, is you don't have to write a line of code just to experiment and see if your data is not really compressible, and it would have sort of the opposite effect of, rather than reducing the file size, it bloats the file size, and then that, of course, would reduce your read performance typically. And now a related question is sort of this next question, and sort of that's why I'm just moving on here. So the question is there any difference in reading a variable or a field if it is compressed or uncompressed? Yes, for sure. There is no difference, assuming there are, of course, two different kinds of compression. There is lossless compression, like gzip, for example, and then there is lossy compression, where at your discretion, if you think it's permissible within, and then there are typically for compression methods like ZFP, you control over tolerances what is permissible in terms of loss. So if you say you can specify that either through an absolute tolerance or relative tolerance and so forth, so ZFP has a lot of options there. But let's assume we are doing lossless compression. Of course, in terms of value, there's absolutely no difference between the compressed and the uncompressed data. As far as the performance is concerned, of course, just sort of from first principles, let's assume that compression has the desired effect in the sense that the bytes that you are that you store on disk, the size, the total size is less than when you have decompressed it in memory. Assuming that that's the case, just back of the envelope calculation. So if you reduce this, let's say by a factor of 2 or more, but let's stick with 2, that means that, of course, you would read only half of the data versus reading the uncompressed data. So you definitely would see a reduced demand for bandwidth, so to speak, because typically your application is not the only application running on a system. There are other applications competing potentially also for bandwidth, so you would be less demanding in terms of bandwidth. But of course, you would offset that with you are reading that compressed chunk that now is only half the size, for argument's sake. However, then you have to invest CPU cycles, or you might have a hardware-based decompressor that is possible too. Of course, you have to then invest some cycles, CPU cycles or hardware decompressor cycles, to actually do the decompression in memory. Now, typically, the speed of decompression is higher than sort of the I/O throughput. So typically, unless your data set is very small, there is a payoff in terms of trading CPU cycles for bandwidth. There is a payoff typically pretty quickly. But if that differential between the time that it takes to decompress the data versus transferring a small amount of data, once you are sort of below this crossover point, there's not going to be any gain. So it really depends on if you have a fast NVMe attached SSD or something like that. These things are extremely fast, and if your data is not big enough, so to speak, then you may not see a difference, because the transfer from that disk is so fast that even though then you do the decompression, and maybe the decompression is even multi-threaded and whatnot, that may not offset the reduction in transfer time. So the answer is it depends. There is a good chance that you will see a benefit, but your mileage may vary, as they say. Yeah, I talked about the pathology. Again, there are pathological cases where if you are using an unsuitable compression algorithm for data, the size of the compressed data in the file may actually be bigger than the uncompressed size in memory. And yeah, that's something to look out for, but it can happen. That's the only thing I want to point out. And then we talked about this briefly last time. There is a hyperlink here to a nice document that describes the, I forgot if, I can open this here, that describes sort of the read pipeline. What happens, there is a nice flow chart in here. Well, first of all, it gives you an overview of chunking and the corner cases and what can happen and checksumming and whatnot. And then down here is sort of this nice flow diagram, what happens in the library when you are reading a chunk from a data set in an HDF5 file. And that, of course, there could be multiple filters. This is a filter pipeline, so often the filter pipeline has just one stage. There's one filter, gzip, for example. But then there could be multiple filters, and then sort of you will basically apply filter one by one, depending on which order they occur in this pipeline. And but this is a very nice diagram, and then there could be data type transformations, value conversions involved, and so forth, that make this a little more complicated. But this is a nice document, and if you have questions, ask a question next time and we'll come back to this. But this is a nice explanation of what happens in the case of chunking. And by the way, if you want to use compression through the filter pipeline, then in terms of layout, chunking is your only option. It is not supported. Chunking through the filter pipeline is not compression through the filter pipeline is not supported with other layouts than chunking. So for contiguous data sets, compact or external layout, well, with compact, they're very small already, as we said, 64K. Well, there isn't probably a whole lot to compress there. But then compression does not work with contiguous layout. And yeah. Okay, and then the third question was, any recommendations for figures of merit to measure capture I/O improvements? Any considerations based on current supercomputers, hybrid systems, number of files used, kind of I/O, HDF5 versions, features? Yeah, right. My recommendation here would be to definitely you need a baseline. Without a baseline, there is no improvement. That's the first thing, and I mean, it's pretty obvious, but it's important to point out that you have to set the baseline, because this is also difficult. Frequently, when we speak with users and we discuss problems and so forth, they sort of give us all kinds of different scenarios and so forth. But at the end of the day, if the question is really, well, have I improved anything? Have I done anything? Without a baseline, there's just no point of reference, and you are just all over the place, and it muddies the water and makes any kind of diagnosis difficult. So it's important to say, this is the point of reference, this is the baseline, and everything is with respect to this baseline. So, and then of course, to measure any kind of improvement or deterioration in performance, you need a metric. And the metric could be, again, things that are important to you, that are not, I mean, there are certainly hot contenders, things that we see again and again and again, but for a specific application, which of these contenders is important to a user is not always predictable or not obvious. So in your application, it could be a trade-off, and it's typically a trade-off between these sometimes competing metrics like file size, throughput, or I/O operations per second. And because you might say, well, to me, my storage is very expensive, and I'd rather compress or reduce my file size to the utmost minimum because cost is much more important to me than spending extra cycles, spending extra runtime on doing compression or doing some more research on finding a better compression algorithm. Because if I can save in my storage budget, that's much more important to me than 24 hours extra research or runtime. Or but then other people have other constraints and other objectives. So if throughput is the be all and end all, well, that's your choice, and there's nothing wrong with that. but it's really that has to be part of the package. Now, so what you will run into very quickly, and that's sort of implied in that question here, is you will have to deal with large numbers of combinations of things. So even if you have your baseline, I like to compare some of the settings in the HDF5 library, and beyond, to sort of a dashboard, and then there are all these knobs and dials, and in some cases it's pretty clear what a knob or a dial does, but there are plenty of other knobs and dials where it's not clear what they do, what the interdependence between the settings is, and so forth. So what we found useful is to use polar diagrams, and I linked here, we recently had a webinar, let's see, where did it go, here. We recently had a webinar, and I put the link in here, and it's just going to start playing. I hope it's jumping to the right place. Let's see. Did I link the, oh, I hope that, sorry, I really don't like, I must have linked the wrong, and I'm going to stay here. This is a polar diagram, and the way we like to visualize this explosion of parameters and choices is, so in a polar diagram, you have basically two variables to work with. One is sort of this radial component, and that's typically your metric, your throughput, your file size, your I/O ops, whatever you choose, or it could be just the timing of a certain phase in your algorithm. That's the radial component. And then there is an angular component, obviously, and we use that to represent these many different combinations of parameters. Of course, the main challenge here then is that you need some kind of a mental model or a separate diagram that explains basically the mapping from angles to parameter combinations, because typically, let's say you have 10 parameters, so you are basically serializing potential choices in this 10 tuple space. You are serializing them, you are enumerating them, and you need some understanding of how angles map to combinations. But once you've done that, it is then very easy to visualize. So typically you have a baseline here that in this particular example was runtime, and so this was a circle here, which would mean radial component is runtime, which means constant runtime. So our baseline is we are saying, well, in an ideal world, all these different parameter combinations wouldn't really do anything. The runtime would be constant. And then you are basically looking at, in reality, how does my real world performance deviate from that baseline? And in this case, well, yeah, if you end up with a radius smaller than your baseline, that's clearly an improvement. And if you fall outside that radius, in the case of runtime, that is a loss in performance. Of course, if that radial component stood for file size, then a smaller file size would be better, whereas a larger file size, again, depending if file size is the most important quantity for you, then that's the case, but if not, then something else. So your mileage may vary depending on what that radial metric stands for. But so going back to the original question, we found that this is actually very helpful, especially in the face of, well, yeah, then you can vary storage, going to the parallel file system, or going to burst buffer, or going to a locally attached NVMe. And then you can all sort of assess that or see that in double quotes with respect to your baseline. And yeah, unfortunately, we are running out of time, but I hope I have given some leads on where to go from here. And if there are more questions, leave more questions in our Google Doc, and we'll come back to that next week. I would point out two things, two announcements that we have. Number one, we have our HUG event, our HDF Users Group event coming up in October. And today is the deadline for submitting papers, papers and presentations, or presentation abstracts, that is. Please, you have time until, I don't know, midnight Central Time or something. And there might be a little grace period here, so maybe that deadline is not as hard as it sounds like. And then in terms of what we saw on the forum, there was an interesting announcement about HDF5 UDF now running on macOS with some caveats. And then with respect to this event, I posted earlier something where I encourage people, we really would like to know, are there certain little things? And without defining little, not in the sense that it's not going to cost us anything to make a change in HDF5, but little in the sense that it's just this nagging detail that makes your life more complicated than necessary in your dealings with HDF5. And if you have an idea of what you would like to see fixed in HDF5, I would like to collect these things. And then at this event, hopefully the people who submitted some of these things will be present, and they can sort of give us more detail on why this is such an annoyance and such a problem for them, and why we should fix it. And I think that would sort of help us to make better decisions about what to do next with the resources that we have. And that's all we have time for. We'll talk about user blocks and gem-packed HDF5 files next time. Thank you very much for coming, and keep submitting questions. It's really, it just, unfortunately, we didn't have a chance to talk about other questions, but keep them coming, and we'll try to accommodate as many as we can. Thank you. Have a good day.